Well, hello. In this video we're going to talk about special cases, but this is the elimination edition. Let's get to it. Let's talk about our first example. Our first example is going to be y is equal to 2x minus 4. And then our other equation is negative 6x plus 3y is equal to negative 12. Now this might look familiar. Let's get into it. Now, when we were talking about solving by elimination, first thing we had to do is stack up or align the variables just right. So in this case, the top equation, we're going to put it into a pseudo-standard form. We're going to move the 2x to this side by subtracting 2x from both sides. So the top's going to be negative 2x plus y is equal to negative 4. Right? Subtract the 2x from both sides on there. And then the bottom equation, I'm going to keep it the same as negative 6x plus 3y is equal to negative 12. So next thing that we need to do is we need to multiply by something so that we have opposite coefficients on one set of variables. Let's get rid of this this x. So I got negative 2 and negative 6. I need them to be opposite. What's the least common multiple of 2 and 6? Well, it'll be 6. I can multiply the top by 3. Or more precisely, multiply by the top by negative 3 so that I get a positive 6 up top. I'm going to leave the bottom the same. But anyways, the top's going to be positive 6x minus 3y is equal to negative 4. And then the bottom, leaving it the same, negative 6x plus 3y is equal to negative 12. Oops, what did I do wrong? You're right. This top should have been multiply lottie-dottie body Smith, including a negative 4. This should be positive 12 up top. My bad. If you caught that, good for you. So, check this out. When I add this up, the x's are going to cancel just as we designed it to. But what's the thing? So are the y's. The y's are going to go and cancel too. So what remains on this left side? If the x's cancel, y's cancel, the only thing that's left is 0. 0 is equal to, now what's 12 plus negative 12? That is 0. So both variables eliminated, but our resulting equation here is true. This is a true equation. So take a guess what you think that's going to be. If you said that this is indeed infinite solutions because they are the same line, you are correct. Both variables eliminated, and similar to what happened when we were doing it with substitution, if both variables disappeared but the remainder was true, that means it's infinite solution, same line. So, with that in mind, you can probably guess what my next example is going to be. How about 6x plus 2y is equal to 3? Not so much what the example is going to be, but how it's going to turn out. Then I got 3x plus y is equal to negative 5. So, same type thing. We have to multiply so that something eliminates. Aiming at x, 6 and 3, that's easy enough. I'm going to multiply the bottom equation by not just 2, but by negative 2. And the top equation, I'm going to keep the same. So the top's going to be 6x plus 2y is equal to 3. But the bottom equation is going to become negative 6x minus 2y is equal to, don't forget it this time, Smith, negative 2 times negative 5 is positive 10. And this time, we're all set. When I add this up, the x's cancel. But so do the y's. So I'm left with 0 equals, but here's the thing, 3 plus 10 is 13. Is that true or false? That is indeed false. So, what is our solution to this system of equations? There is no solution. Why is it no solution? Because they are parallel lines. So this one was infinite solution, same line, because when the variables eliminated, we were left with a true statement. So that means that any point that is on that line is a solution because they are the same line. But on this one, variables eliminate, but we're left with a false statement. So anything there's nothing that I could find for x and y that would make it true in both solutions, or in both equations, so that's why it's no solution parallel lines. So, just like with substitution, if variables eliminate, it's going to be one of the special cases. But the question is it true or false? So, similar flow chart. Do both variables eliminate? If the answer is no, that means there is one solution. And that and you should keep going. And your answer is going to be an ordered pair. It's going to be something like x, comma, y, or alphabetical order of some sort. So, do both variables eliminate? No. Keep going. You're going to get one solution. However, if both variables do indeed eliminate, the next question is the remaining equation true? If it is not true, then that means that it is no solution because they are parallel lines. However, if you're doing your thing and if it is indeed true, that means that it is infinite solutions because they are the same line. So, remember, just a quick review here. One solution means you've got one line and another line, and the intersection point is that solution. No solution, of course, looks like lines that are parallel, that never go and intersect. And of course, infinite solution means that you have one line and the other line is the exact same. Oops, oh my goodness. The other one is the exact same line on top of it, and all of these points are intersection points. That's why it's in infinite solutions. So, that's a video about special cases elimination edition. Smith out!